Once again, taking the derivative can be quite tedious if you use the definition of derivative, so thankfully mathematicians have come through for us again with some more rules that we can apply based on different patterns that they saw as they were finding the derivative. So at the end of this lesson, you'll be able to use the sum and difference rule to find the derivative of a function. You'll notice as we're looking at the sum and difference rule, pretty much again common sense. I probably would just intuitively do this in a problem and it would just magically work out fine. You'll notice if I have two separate functions and it asks me to find the derivative, d dx is the derivative, then basically all we're going to do is take the derivative of each function separately and add them together. Same thing if we're subtracting, we'll just take the derivative of each function separately and then subtract them. So let's look at a few examples. You'll notice in the first example, we have y equals t squared plus 2t minus 3. You'll notice we basically have three parts. We'll just take the derivative of each part and then add them or subtract them. So when I'm taking the derivative, the first one, if I'm applying the product rule, if I bump my 2 out front, this will now be 2t to the first, and then plus, if we're thinking about this, there's really a 1. I'd bump the 1 out front and I'd get 2. And then you'll notice if I reduce that power by 1, I would end up getting 1 minus 1, which would be 0. T to the 0 is just 1, so I really just get 2 there. And then the third part of it, the derivative of a constant is 0. So my derivative is 2t plus 2. Okay, second example. Before I actually work this one, I notice that I have a fraction going on, so I'm going to take care of that before I take the derivative. So this will be x squared minus 3x minus, let's bring that x squared up top, and it will become 3x to the negative 2. Now you'll notice I have three parts. I'll just take the derivative of each part separately. So I'll have the derivative is equal to the derivative of x squared, using my power rule, will be 2x, and then minus the derivative of 3x will be 3, and then minus the derivative, if I use this one, if I bump that out front, actually negative 2 times that negative 3 will give me a plus 6x, and then if I subtract 1, negative 2 minus 1 is negative 3. Okay, and then we could rewrite this one more step because we don't deal with negative exponents right now, so we'll have the derivative is equal to 2x minus 3 plus 6 over x cubed, and that is my derivative. Okay, this next one, we have 2x squared minus 3x plus 1 all over x, and we don't have anything to do yet to deal with fractions. So what I'm going to do on this one is rewrite it, and the way that I'm going to rewrite it is kind of backwards of how you get a common denominator and add fractions. Since this is over the entire thing, I can actually separate it into three parts. So I'm going to make this 2x squared over x minus 3x over x plus 1 over x, because I could easily just put them back together if I wanted. So now notice I have three separate parts, so I'll take the derivative of each part. But before I do that, let's just simplify a little bit. 2x squared divided by x will just be 2x, and then minus 3x divided by x, the x's will cancel, so I'll just get 3. And then this one, if I rewrite, since this is an x to the first down below, if I rewrite it, it would be x to the negative 1. Now I'm ready to take the derivative. And you might notice that, oh man, do I have to do all these steps? It really is easier if you clean it up before you start trying to take the derivative, because that's when people generally get into troubles. All right, so the derivative of 2x will be 2. The derivative of minus 3, since it's a constant, will be 0. And then the derivative of my last part, if I bump my negative 1 out front, it will be minus 1x. And then I'm going to subtract 1 from my power, and notice I'll get negative 2. And so now I'm just going to clean it up one more step. I'll get 2 minus 1 over x squared, and that is my derivative. So hopefully now you can use the sum and difference rule to find derivatives of functions.